What excites you most about the technical possibilities that emerge when you combine advanced capabilities from space, like our microwave soundings, with AI and ML applications? And maybe actually start with you, Forrest, because you're working on that every day.
Yeah, and I guess I can quickly follow on what I was just saying. Like, when I am looking at the possibilities as well as the challenges, again, we really want to address our advances and address what we work on at tomorrow from the scope of what are the existing problems? What are the challenges we want to resolve? Uncertainties in numerical weather prediction systems, complexities in data assimilation systems. How can the new advances in machine learning, AI technologies really help us address these kind of things? How do they link in with our sounder systems? So what I just mentioned on the ability to determine what kinds of observations are really going to help close gaps in predictability, I think we've got some wonderful opportunities there. Pass it.
Thank you. So AI machine learning. Well, let's put it this way. AI machine learning is absolutely necessary to fill, as you said in the video, the gaps, the global observing gaps. I mean, even if you have satellites up there, now take your microwave radars, for example, your active radars, they're going to see at a small swath, and that's vital. But we need a ground truth anchoring mechanism to AI models, and the more ground truth you have, the better your AI models are. So using microwave radar or microwave sounders, those are excellent examples to help provide those kind of ground truth to help anchor an AI model going forward. AI also can help out with help derive geophysical products more effectively and more efficiently. I know that there's a crater that you guys are working with NOAA. I realize we fund a very teeny piece of that with NESDIS STAR, but working on the AI machine learning a little bit. So it's exciting, but it is growing rapidly.
I have to read your question. The exciting part about AI machine learning is combining all types of data, microwave, infrared, and everything else. But we have to make sure that the machine learning is not overtrained. So that's really important. So you got to really understand the real information content. Like, for example, I was dabbling in some machine learning, and I noticed a lot of people put latitude, longitude into the machine learning because, you know, there's climatology background, that's function latitude, longitude. You can like cheat a little bit. I call it cheating machine learning. Like, you can say, hey, if I know I'm over a desert and I know it's daytime, I can get information better on the skin temperature, but the satellite measurement doesn't even see that at all. And so then the machine learning is overtrained, and it won't work well for other seasons. However, it might not be that bad if because people, at the end of the day, you want the best forecast as possible. So there's something called data-driven, right? We call it data-driven AI machine learning. So it might be something that where you have a continuous data flow, and you train it as, you know, with recent data, and you just build up the training, and you have a continuous training, so you don't have that problem. And so we really have to think about how to do the AI machine learning. I think it's very effective at combining information. Again, it's like using your imagination. You can imagine like geostationary imagery, for example, when you see these movie loops, right? There's no reason why your imagination shouldn't say, well, can I predict the next 2 hours of geostationary, because the information content. The same thing with all the Tomorrow I/O CubeSats and all this data. That's why it's called data-driven. It's not called data-sparse AI. It's data-driven, means I need the data. So data's king now, and the problem in the past was too much data, and most of the data wasn't being used. So with AI machine learning, you're going to suddenly revolutionize that. You're going to maximize the use of data, but we just have to be careful that we have the computer resources that allows us to almost continuously update the training, because we want the very best products. So, you know, if you have a seasonal, if you're looking over the desert and you know that desert's hot during the day, there's no reason why you can't use that information if it's going to be continuous updated training. So anyway, it's lot out there, but still, we're going to have to rely on access to computer power, massive computer power, and storage and memory and everything else. And there's a lot of possibilities, but a lot of
Yeah.
testing and experimentation is needed.